All right, let's take a look at question number 4. Problem 4, we're doing the same procedure for problems 1, 2, and 3. We're going to express the given conic in standard form, identify it, find the properties, graph, label, and state the definition of the conic in the context of the problem. Okay? Now, let's consider the equation. The standard, the general form of a conic given by 2y squared plus x minus 16y plus 26 equals 0. Now this is a general form of a conic, but can you identify the conic based on the appearance of this general form? The answer is yes. If you look at this conic, what you notice is that only one variable is squared. Okay? And that is the y squared. So you have only one variable squared, that's automatically a parabola. All right? So this is a general form of a parabola. Now that we have identified what kind of conic it is and the form, we're going to go ahead and convert it into standard form, because in the standard form it's easier to find the properties to generate the graph. So in order to get this in standard form, what we're going to do is collect the variables first. Now you have to note the difference here between the approach we use for parabolas and the other conics, the general form of the other conics. In the other conics, we collect similar variables on one side of the equation and note the constant on the other side. But for parabolas, what you want to do is you want to collect the terms, the variables with the squared term on the left side, and everything else goes on the right side, okay? So I'm going to be collecting 2y squared minus 16y on one side, and everything else goes on the other side, okay? So we're going to subtract x and subtract and subtract 26 from both sides. So let's indicate what we're going to do. We're going to subtract x and subtract 26 to both sides of the equation. So that's going to yield 2y squared minus 16y equals negative x minus 26. Okay? Now the goal is to create a perfect square trinomial on the left side and express that quantity as a perfect square with no coefficient in front of the parentheses. All right? So to make this into a perfect square, we have to first of all ensure that the squared variable has a coefficient of 1. This squared variable has a coefficient of 2, so we need to address that by factorization. So we're going to factor out the 2, and we'll be left with y squared minus, if you factor out 2 from 16, you have 8y. Please do not forget to divide this by 2. And then plus the term that completes the square in the y world. All right? All right, equals negative x minus 26. And then we're also going to be adding something here too. We're going to figure out what that is momentarily. So let's figure out the term that completes the square here. So we have b of y. b of y is negative 8. So to complete the square, you just have to divide that by 2, negative 4, and square it, and you get what? 16. Okay, so you're going to add 16 here. Now we added 16 here. What do we add to the right side? Do we add 16? The answer is no. There's a 2 out here, so we have to add 2 times 16. Okay, so we're going to add 2 times that 16 there. 2 times 16. Okay, so we have to be careful with that too. Now we have a perfect square trinomial in this parenthesis, so we're going to factor it. You read the first and the last, and then you bring down the middle sign. And we're going to have 2 times the quantity y minus 4 squared equals, here we have minus x, and then 2 times 16 is 32, minus 26 plus 32 is positive 6. All right? Now, what can we do next? We can factor out negative from these two quantities right here. We have 2 times y minus 4 quantity squared equals negative x minus 6. Okay? And then this 1/2 has to go because in the standard form of the equation of a parabola, you don't have any coefficient in front of the squared quantity. So to accomplish that, we'll just simply multiply both sides by 1/2. So multiply by 1/2 and multiply by 1/2. Okay? So that's going to yield y minus 4 squared equals negative 1/2 x minus 6. Okay? So that's the equation of our parabola in standard form. Standard form. All right, now we're going to go ahead to look for the properties. Okay, so let's find the properties. First thing we're going to do is identify what kind of conic this is. We already determined that. Only one variable is squared, so we have a parabola. Parabola. Okay. All right, so next thing we're going to find is the vertex of the parabola. So it's HK, so we have to be careful here. You take the coordinates of the number next to the x, -6, you do the opposite of that, which is 6, and the opposite of the number next to the y, -4, the opposite of that is 4. Okay, so there goes your parabola, the vertex of your parabola. Now, next thing we're going to find is the opening. Okay, now, how do we know where the parabola opens? You want to note that the parabola always opens in the direction of the unsquared variable. Okay, the variable that's not squared here is the x variable. So we know the x direction goes side to side, which tells me that the parabola is either going to be opening to the left, negative, or to the right, positive. Okay, so since there is a minus here, that automatically tells us that the parabola opens to the left. Okay, so the opening is to the left. It's going to look something like this. Okay, now next thing we want to find is P of the focus. P of the focus. All right. To find P of the focus, we're just going to set the coefficient of the factored unsquared quantity, -1/2, equals to for P. We solve this for P, and that will give us what P of the focus is. All right. Remember the formula, A is equal to 4P, where A is the coefficient of the unsquared quantity. Now let's isolate P here. To isolate P, I can simply multiply both sides of this equation by 1/4, as opposed to dividing by 4, which will not look too nice. To multiply by 1/4 on both sides, and then we'll have P equals -1/8. Okay? So this tells me something. This negativity tells me is either going left or downwards. Since the opening is to the left, the focus always goes in the direction of the opening of the parabola. Okay? So this quantity right here is basically telling us that the focus is going to go, let's write that again, it's going to go 1/8 units to the left from the vertex. Okay? All right, now that we have P of the focus, let's determine what the directrix of our parabola. Okay, so let's go ahead and write that down. Directrix. Directrix. Now, how do we know where the directrix is? The directrix is going to be 1/8, positive 1/8. Okay, or 1/8 units to the right of the vertex. Now, how do I know that this is the result, or how do you determine the direction of the directrix? You simply do the opposite of what the focus is doing. Since the focus is going 1/8 units to the left, the opposite of that is 1/8 units to the right. Okay, that's how the directrix and the focus interact. Okay, the directrix is also the equation of a line. So since we're going up, since we're going side to side, the directrix is going to be going up and down. So if you have a vertical line going up and down, and the directrix is 1/8 units to the right, then you can think about what the equation is going to be. It's going to be x equals the x coordinate, which is 6 plus 1 over 4. Alright, it's much easier to generate the equation of the directrix graphically, so let's go ahead and generate the graph of our parabola, okay? The center is the vertex is 6, 4, which is located in the first quadrant. So let's go ahead and draw our axis accordingly, making quadrant 1 sufficiently large to compensate for the shifts. Now, let's go ahead and graph the vertex. So we're going to go 6 units to the right, 1, 2, 3, 4, 5, 6, and 4 units up, 1, 2, 3, 4, 6, 4. There goes the center, the vertex. Now the parabola opens to the right, so this is just a sketch. A parabola looks something like this, opening to the right. Okay, now let's go ahead and label our parabola. Let's start off by labeling the vertex. This is the vertex right here, the vertex. And the coordinates of our vertex are 6, 4. I like to draw the axis of symmetry because that line contains the focus and the vertex. Okay, so that line right there that divides our parabola into two congruent curves is our axis of symmetry. Okay, so let's go ahead and label that also. So this is your axis of symmetry. Axis of symmetry. Alright, so our axis of symmetry has an equation of the form y equals the y coordinates of our vertex, which is 4. Y equals 4. Okay? Alright, I'm going to move my labels in another direction in a second. Okay, I shifted my labels to the left because they seem to be interfering with the directrix. Alright, so there goes my axis of symmetry. This line right here, y equals 4, and there goes my vertex. Next thing I want to graph is the focus. The P of the focus is 1/8 units back, so we're starting from 6 and you go back 1/8. It's going to be somewhere very, very close to 6. Okay, I'm just exaggerating it here. So there's your focus. Bring it down. And then our focus is going to be the x coordinates. You just subtract 1/8 from 6, so 5 and 7/8. And then the y coordinate stays the same at 4. So there goes your focus. The next thing we're going to graph is the directrix. So the focus goes 1/8 units to the left. The directrix is going to go 1/8 units to the right. So somewhere there, I kind of exaggerated it a little bit, is much closer. So let's graph the P of the focus. Alright, and then what are the coordinates of what is the equation of the line of our directrix? So this is our directrix right here. So it goes through the x-axis at what value? We're going to go 1/8 units to the right. So that is a line that's constantly x equals 6 plus 1/8, which is 6 and 1/8. Okay, so let's go ahead and label that line. So this line is our directrix. Directrix. And it's easy to see that it is x equals 6 plus 1/8, which is 6 and 1/8, or 49/8. Okay, so that's the equation of our directrix. Alright, so that's that. Now let's write a definition of parabola in the context of this problem. Definition: the locus of points whose distance from a fixed point, the fixed point is the focus, fixed point 5, whole number 7/8, and 4, and the line is going to be the directrix, and the line x equals 6 and 1/8, is the same is the parabola with the equation. And then we can write down the original equation: 2y squared plus x minus 16y plus 26 equals 0. All right, so that's that. So thanks so much for taking the time to watch this presentation. You can feel free to subscribe to our channel for updates to other cool clips such as this. And please post a comment to let us know what you think about this presentation. More clips can be found at matclubserve.com. Thanks again for watching and have a wonderful day.